here in this first example, the left side is already condensed into one single log. The right side, I can condense it, again, positive and a positive. They both come from positive logs, so they're factors in the numerator, so 4x. So this is my condensed form. Once each one is condensed into a single log, you can use the one-to-one property, which means that if those expressions are equal, then the values in the inputs have to be equal as well. So I know that negative 5x plus 7 has to equal 4x. And once again, it becomes a linear equation. If I add 5x to both sides and divide by 9 to isolate my x, I get 7/9. Now, before I would hit enter, you want to double check. Make sure when you plug this number in, do you get negatives anywhere? So I do need to be concerned with this value. If I plug in a number that's less than 1, this value is going to go down. So it's going to be less than negative 5. So when you look at that, the difference between the negative number that's less than 5 and 7, it's still going to be positive. So you're okay there. So this is your solution. However, in the second example, if you work through and condense on the left side, nothing changes. We leave it as it is. On the right side, again, we get 2 positive logs, so the inputs will be factors in the numerator of the single log, so 8 and x. So once again, we equate our inputs, getting negative x minus 5 is equal to 8x, a linear equation. Add x to both sides, and when you solve, you get x is equal to negative 5/9. Now, when you plug this in here, what's going to happen? It's going to be a negative value. Can you take the log of a negative? No, so this one would be does not exist.